Hello and welcome to the Gulf Coastal Plains and Ozarks Landscape Conservation Cooperative's webinar presenting the results of a project entitled Protecting Open Space and Tidal Wetland Migration Corridors to Increase Coastal Resilience in the Gulf of Mexico. Today we will present the results of two projects focusing on coastal resilience and specifically how the PIs collaborated in outreach to local communities in the northern Gulf of Mexico. The GCPO LCC focuses on strategic landscape conservation that will be adaptive to future change within a 180 million acre geography centered around the lower Mississippi River. So today I have the honor of introducing Michael Osland, research ecologist at the USGS and also research staff with the GCPO LCC, who was PI on the project entitled Incorporating Future Change into Current Conservation Planning, Evaluating Wetland Migration Along the Gulf of Mexico under Alternative Sea Level Rise and Urbanization Scenarios. Our second presenter is Chris Shepard, Director of Science for the Nature Conservancy's Gulf of Mexico program and PI on the project entitled The Economics of Coastal Resilience and Open Space. Papers related to both projects are available for download for you guys. You should see that in your control panel. So before I hand it over to Mike, I am going to issue the first poll question, which is just going to tell us a little bit about who you are. So if you guys could just fill in, choose the category that seems to fit best. It's great. You guys are quick voters. I have 91% of the votes almost. Everybody's voted, okay? So here's the results. We have a lot of research scientists. We have a few local planners and consultants and some NGOs and habitat managers. A good mix. So now I'm going to hand it over to Mike. And you may need to unmute yourself, Mike.
Okay, well, good afternoon. Can everyone hear me?
We can hear you.
Okay, all right. Well, thank you. Thanks for attending the webinar this afternoon. I have a presentation that I'm going to give about the Wetland Landward Migration Project. And so the format for this webinar is I'll be presenting about that project for roughly 20 minutes. And then Chris Shepard is going to present about the workshops and the outreach in the second portion of the webinar. So the title for my presentation is Barriers to and Opportunities for Landward Migration of Coastal Wetlands with Sea Level Rise. And my co-authors on this work are Nicholas Enright, Corrine Griffith, and Sinead Borchert. And this work was supported by the US Fish and Wildlife Service, the USGS Ecosystems Mission Area, and the two Department of Interior Climate Science Centers, the Southeast and the South Central. And we received input regarding this work from the 4 Gulf Coast Landscape Conservation Cooperatives. So that includes the GCPO, the Gulf Coast Prairie, the South Atlantic, and the Peninsula of Florida LCC. And this is the study area for our work. So it included all 5 states, US states on the northern Gulf of Mexico, Texas, Louisiana, Mississippi, Alabama, and Florida. And this is a map from a paper that is available, I think, through the Median software. It's a paper Enright et al. In Frontiers in Ecology and Environment. And I'm going to be talking a lot more about this paper throughout the talk. This is the title, and it came out in 2016. So before I begin, I'm going to use the term tidal saline wetlands, and I want to make sure that we're on the same page when I use that term. And so I've got a quick photo tour of the Gulf of Mexico, beginning in South Florida, where it's hot and wet. And so the most common type of coastal wetland in that area are mangrove forests. And as you move up the coast of Florida, when you get to Cedar Key, it's cold enough that salt marshes begin to enter the mix. And there you have a mosaic of mangrove forest and salt marsh. And then as you get into the colder and more northern parts of the Gulf of Mexico, freeze events are frequent enough that salt marshes dominate and mangrove forests are less prevalent. So here's some photos from Grand Bay, and also McFadden National Wildlife Refuge in Texas. And then as you enter the middle Texas coast, you begin to enter a precipitation gradient, which results in hypersaline conditions, and you begin to get succulent-dominated salt marshes. And once you reach the Texas-Mexico border, specifically the Laguna Madre estuary, you have these salt flats. So it's a totally different type of coastal wetland in that arid and hypersaline part of our Gulf of Mexico. So when I use the term coastal wetland or tidal saline wetland, I'm really referring to all those different kinds of wetlands: the salt flats, the succulent-dominated salt marshes, the graminoid-dominated salt marshes, and the mangrove forests. And all these different kinds of wetlands provide many different important goods and services. Coastal protection resilience, which we're going to hear a lot more in the second half of the webinar. Extremely high rates of carbon burial, carbon storage, fish and wildlife habitat, seafood, recreation, and so on and so forth. So because of that, there's a lot of interest in ensuring that these wetlands can adapt to sea level rise. They're very sensitive to many different aspects of climate change. And in this talk, I'm going to be focusing primarily on sea level rise and saltwater intrusion. So here are different scenarios from a recent NOAA report, Sweet et al. 2017. These are scenarios for the US National Climate Assessment. And the highest scenario is a 2.5 meter sea level rise by 2100. And on top of sea level rise, coastal development can also affect the ability of coastal wetlands to adapt to future change. Coastal cities are expanding rapidly. 39% of the US population lives in coastal counties, and that's expected to increase in the future. Here's the statistics for the period we're in now, between 2010 and 2020. The expected increase in US coastal counties is expected to outpace the increase in other parts of the US. And just to drive that point home, here's a map of housing density in 1940, and pay attention to the red, 1990 and 2030. And I'll go back and do that again real quick, 1990, 2030. And so that coastal development affects the ability of coastal wetlands to migrate horizontally in response to sea level rise. Coastal wetlands are actually able to respond to sea level rise via vertical movement, these really interesting biogeomorphic feedbacks, as well as horizontal movement, landward migration. And in this project, we're focusing just on that horizontal movement. So our aim was not to predict whether current wetlands could keep pace with sea level rise via the vertical movement. We wanted to tackle a simple portion of this question, which is the horizontal movement. And so I'm going to say that again, just to be really clear. Our goal with what I'm going to talk about was not to predict whether current wetlands could respond to sea level rise via these ecogeomorphic feedbacks vertically. We wanted to isolate a really specific question that focused on the horizontal movement of those wetlands. So where might they move landward at the expense of adjacent upslope and upriver ecosystems? And so I might use the term landward migration or transgression to describe that process. Here's a really simple cartoon illustrating what I'm talking about. So you have a salt marsh and a mangrove forest and the existing sea level, and then you have the adjacent ecosystems. They could be an upland or freshwater forest or a freshwater marsh or upland grassland. The type of wetland and upland ecosystem really varies tremendously across the Gulf. So these are cartoons that are meant to illustrate some of that diversity. And with sea level rise, what we wanted to do was identify that space where horizontal migration could occur. So the area that's in the red box in this cartoon. Now where there's development or levees, there's a barrier to that migration. So we also wanted to identify those areas where there's not space for migration due to some barrier. And it could be an anthropogenic barrier, for example, urbanization or levees, or it could also be a topographic barrier, areas where the natural topography prevents wetlands from migrating horizontally. So here's a cartoon with high slope, and the red box is smaller, and an area with low slope, and so the red box is much, much larger. So the key questions for the project were, first, where can that landward migration of wetlands occur, where across the Gulf in those 5 different Gulf states, Texas, Louisiana, Mississippi, Alabama, and Florida. And then second, where are there barriers for that migration? And the barriers that we focused on were current urban lands, future urban lands, levied lands, and also that natural topography, of course. And then third, how can existing protected lands accommodate the landward migration of tidal wetlands, tidal saline wetlands? So again, a lot of the results that I'm going to present are from this paper. We have another paper that's currently in review where Sinead is the lead author on this other paper. And so I have some figures from the subsequent paper as well in this presentation. So again, this is the study area, and all those blue boxes are different V-datum regions, which we use to identify that coastal wetland upland boundary. And so that boundary is affected by a lot of different factors. I'm not going to get into too much detail, but it's covered in that manuscript as well as a data series report. But that boundary is affected by tidal range, landscape position, watershed properties, and climate as well. And so we identified the boundary between upland or freshwater ecosystems and current wetlands relative to a tidal data, mean high or high water. And we did that using elevation data as well as current wetland data. So data from the NWI habitat data. And for future urban growth, we used data from this paper. Adam Tarando et al. Used SLEUTH, which is an urban growth model for the southeastern United States. And that's the future urban growth data that we incorporated. And then we also incorporated current urban lands and current levied lands. And so we combined all those different sources of information. So the future tidal saline wetlands, the current urban lands, current levied lands, and future urban lands into a data set that looks like this. And so this is just an example from the Texas coast. And so there's all these different classes. This is for a 0.5 meter sea level rise by 2100. There's the current tidal saline wetland, which is in magenta, the future wetland, which is in light pink. And then there's all these different combinations of classes. So for example, the red, those are areas that are currently urban, but they're low enough that they would be expected to be future wetland if they weren't protected by a levee or something like that. And then the areas in green are levees, and the dark green are areas that are higher, and then the light green are areas that are low enough that without that levee they would be expected to become wetland. And so there's all these different combination of classes. And this is a 0.5, this is a 1.2, and this is a 2.0. And this data is available at this resolution for the entire US Gulf of Mexico coast, for all of Texas, all of Louisiana, all of Mississippi, all of Alabama, and the Gulf Coast of Florida. And so this is just one example, but this data is available for download and also in a viewer at this resolution for the entire Gulf Coast. So I'll go through it again. Here's a 0.5, here's a 1.2, and here's a 2.0. And so one of the questions that we wanted to address was, first of all, how much area is available for landward wetland migration? And unlike much of the rest of the United States, especially the Pacific coast, there's a lot of land available for migration on the Gulf Coast. As you'd expect, it's a very, very flat and low-lying coast, and so a lot of migration expected in the future. And so this figure shows the area on the y-axis, and then there's 3 different sea level rise scenarios: a 0.5, a 1.2, and a 2.0 by 2100. And then the different colors just reflect those sea level rise scenarios. The blue is those areas where landward migration is possible, and then we have the barriers due to current urban lands, future urban lands, or levees in the red bars. And so in follow-up to that work, we've currently got a paper that's in review, and Sinead is the lead on this paper, where we compared all 39 estuaries in the Gulf Coast. And so this map shows the 39 estuaries that we evaluated, and so there's our different codes for individual estuaries in those 5 states. And we assess the area available for landward migration within each of those estuaries. And so here's a map of those 39 estuaries. and the blue reflects the potential, the opportunity for wetland migration. And so if it's a light blue, there's very low opportunity. If it's dark blue, there's very high opportunity. And so what this map highlights is the different estuaries where there's a lot of migration expected. So as you'd expect, most of the estuaries in Louisiana and South Florida, there's a lot of opportunity for migration, as well as the estuaries in the eastern part of Texas and certain estuaries in Mississippi and Alabama and the Big Bend region of Florida. Another interesting result of this paper that's in review is the ranking of estuaries according to the urban barriers. And so this map identifies estuaries with a high amount of urban barriers that are expected to prevent migration. So these are low-lying urban lands that if they weren't urban, those low-lying lands would become wetland. And so the intensity of the red reflects those urban barriers. And so this map really highlights certain estuaries, especially those in Florida, the Tampa Bay, Charlotte Harbor, Crystal River, as well as a few in Louisiana, the Atchafalaya, Barataria, Mermentau, and also Galveston Bay. And I'm going to show another plot that highlights those estuaries in a second in a different way. So here's a comparison of the 39 Gulf estuaries for a 1 meter sea level rise scenario. And there's two different axes. The y-axis is the amount of barriers. So those are urban barriers to wetland migration, and it's relative. And then on the x-axis we have the opportunity for wetland migration. It's relative. And so what's kind of neat about this plot is it really highlights certain estuaries where there's a lot of opportunity for migration. For example, the Atchafalaya, Vermilion Bay, Mermentau River, Barataria Bay in Louisiana, and then in Florida, the North and South 10,000 Islands. And it also highlights certain estuaries where there's not very much opportunity for wetland migration, but there's a lot of urban barriers to migration. Those include the Charlotte Harbor, Tampa Bay, Crystal, Pisla, Chascudi, hope I'm pronouncing that one correctly, and the Galveston Bay. So those are estuaries where there's a lot of low-lying urban lands that are expected to prevent migration. So again, this is all in a paper that's in review right now. And it also includes specific figures for different states. So this is just an example for Florida, but we also have figures for the Alabama, Mississippi, and Louisiana coast, as well as for Texas. And it shows how those estuaries change under different sea level rise scenarios. So the top panel here is a 0.5 meter sea level rise, the middle is a 1.0, and the bottom is a 1.5 meter sea level rise scenario by 2100. And it shows where those different estuaries are located in terms of the opportunity for migration, as well as the urban barriers under those different scenarios. So for example, if you look at the 10,000 Islands triangles, that's the STTI and the NTTI, you can see under the different sea level rise scenarios how those triangles move along the x-axis. And similarly for Charlotte Harbor, Tampa Bay, and the Crystal, Pisla, Chascudi, which is the CP, the TB, and the CH, those triangles, you can see how they move up, especially under the 1.5 meter sea level rise scenario. So there's very little movement under the 0.5, but the amount of migration and barriers to migration under the 1 and 1.5 are much, much larger. So those are just some of the products from this project. And so some of the take-home messages are, first, that there's a massive amount of land available for wetland migration along the Gulf Coast. There are also certain estuaries that have barriers to migration, and those could be due to levees, current urban lands, and in some cases, future urban lands. And so this is a figure from that Enright et al. Paper that highlights the different scenarios that we had evaluated. On the top, we have a scenario where there's a lot of migration expected, and that's especially the case in South Florida and Louisiana. The E and F panels identify areas where natural topographic barriers are expected to prevent migration, and that's the case in South Central Florida and the Panhandle of Florida and parts of Mississippi and South Texas. And then the I and J panels identify a scenario where low-lying urban lands are expected to prevent migration. That's especially common in the Tampa to Fort Myers region of Florida, as well as estuaries I just talked about, Galveston Bay, the Crystal, and then also certain estuaries in Louisiana. And then the bottom panels reflect the scenario where a levee is expected to prevent migration. That's especially common in South Florida, Louisiana, and certain parts of East Texas. So we've got a lot of different products from this work. One is a data series report. Another is the data themselves. So the data is available for download via Sciencebase. And if anybody's interested in these links, you can send me an email and I'll get you the information. The data is also available for viewing in the GCPO LCC Conservation Planning Atlas. And we have the Enright et al. Manuscript and then the Borchardt et al. Manuscript that's currently in review. And then Christine is really going to talk about the workshops and outreach. So Christine and Sinead conducted a series of joint workshops this summer. And here's a map of the location of those workshops. And so they included the Aransas Bay, Calcasieu, West Mississippi Sound Estuary, Pensacola, Tampa, Mobile, and Charlotte Harbor. And so Christine's going to talk about all these workshops in the second portion of this webinar. And that's all I have, and I'm going to hand it off to Christine, and I think we're going to have time for questions at the end of her presentation.
So I'm making you a presenter now, Christine.
Okay, sounds good. Okay, can you see that okay, Greg?
Looks great.
Okay, great, thank you. So as Mike mentioned, I'm going to be talking about a project that TNC led in conjunction with Texas A&M, our open space project, and how we collaborated with USGS for outreach across the Gulf of Mexico related both to the wetland migration science, which Mike just presented on, and the open space project that I'm going to share with you now. The co-authors for this project were Dan Micah and Joe Fargione from TNC, North America Science, and Sam Brody and Wes Highfield from Texas A&M University. I just wanted to share a little bit about how we arrived at this project. TNC has been active with other collaborations and partnerships working on coastal resilience and the science of the role that nature can play in increasing community resilience for over 10 years now. And much of my previous work has focused really on the shoreline and the role that coastal habitats can play in terms of storing water and attenuating waves and decreasing coastal erosion. So this Protecting Open Space and Ourselves project was really our first look Gulf-wide across the 5 Gulf states to start to think about where open space protection, so acquiring land to reduce flood risk and meet conservation objectives, could be explored further. The coastal resilience approach that we apply for these types of analyses and projects, both at the regional, state, or local scale, is a pretty typical risk assessment and mitigation framework. So the first step is assessing risk. Next step is identifying solutions. That's where things like living shorelines or oyster reef restoration projects or buying land come into play. Taking action is implementing those projects, and then measuring effectiveness is quantifying the risk mitigation benefits of those projects. So as I mentioned previously, much of our work is focused on identifying solutions right at the coastline, and we're trying to take more of a watershed-based approach to thinking about coastal resilience at the watershed scale, and thinking about how land use decisions impact flood risk, and also how we can identify projects to meet our conservation objectives while at the same time reducing flood risk. Our coastal resilience is also a network of practitioners and projects across the United States. So some of the work I'm going to be sharing today stems from pilots that were initiated in other states. And I urge everyone, if you're interested, to check out coastalresilience.org, which is our global website that houses a lot of the information about these projects in the Gulf of Mexico, the network of practitioners and projects and all the science that we've contributed to, led, or developed. Most people, when they hear about coastal resilience and thinking of TNC, they're thinking about our online mapping tool. And I just wanted to put the link up here for this today, because on our Gulf of Mexico coastal resilience web mapping tool, we do have the data sets that are related to the open space study that I'm presenting on now, as well as the wetland migration data sets that Mike previously just presented on. The coastal resilience mapping tool is organized into apps, and each of the apps kind of focuses on different aspects of decision-making related to building community and coastal resilience. And I just shared this with you today so you can understand one of the slides I'm going to show in a little bit, which is that we're taking some of this information and some of the feedback from the workshops and developing it into an open space app on coastal resilience. So this is a really important and critical point to make when we start to think about wetlands and what role land protection can play in reducing risk, is that, you know, reducing risk involves multiple solutions. So nature is not going to be a magic bullet that's going to make our coastal communities resilient to flooding and climate change impacts, but it very much so should be one of the options that's on the menu of items that are considered in terms of managing a community's flood risk and reducing their risk in the long term. And so when we talk about protecting open space to reduce flood risk, we're really thinking about, okay, this is a nature-based solution, and we're also thinking about development choices. How is the land use impacting flood risk and flood claims in these watersheds? Across the Gulf of Mexico, the Nature Conservancy and our partners are involved in a wide variety of projects and activities and science projects, all with the aim of increasing coastal resilience. And so some of these projects are restoration for ecological resilience, so primarily protecting areas that are likely to be resilient to the impacts of climate change. So some of these areas that Mike has shown that are likely to have space to migrate and have limited barriers. So projects that focus on those types of habitats and those areas are restoration for ecological resilience. Alternatively, there's restoration projects for community resilience, primarily benefiting people. So this is where we're putting in habitat projects, living shorelines, purchasing lands to reduce risk to people. Acquisition for risk reduction also falls under the community resilience category. And then non-structural approaches, so that has to do a lot with the science of planning and zoning and analyzing how different choices about land use affect risk. Watershed-based restoration, we have quite a bit of work ongoing in those categories. And then economic evaluation, so trying to get at the cost effectiveness of these different types of approaches. And that's something I'll talk a little bit about when we get into the FEMA community rating system. So the Protecting Open Space and Ourselves project, this is a screenshot of the actual hard copy report, really starts to look across the Gulf of Mexico and propose a method for identifying which watersheds across the Gulf of Mexico make sense for considering purchasing lands to reduce flood risk and meet conservation objectives. And so really we wanted to say, you know, what are the methods for identifying high flood risk areas, and what's a potential method for identifying areas of high conservation opportunity, and can we begin to overlay those maps Gulf-wide to get a good sense of where it makes sense to do a deeper dive with these communities on thinking through purchasing lands, acquiring parcels to reduce flood risk. So for this analysis that we completed in partnership with Texas A&M, this is the watersheds across the Gulf of Mexico that were included in the analysis. We did have an area in Texas that we were unable to get the National Flood Insurance Program claims data for, so it was excluded from the analysis. But you can see these are HUC 12 watersheds across the Gulf Coast, and we matched the boundary of these to the Restore Act boundaries as best we could for the analysis. And so Looking across these watersheds, there's 2,658 of them. We calculated for each of these watersheds the total dollar amount of National Flood Insurance Program claims. So those are residential flood claims that had been filed. And in addition to the NFIP claims data, we also calculated a whole range of control variables related to the socioeconomic conditions of those watersheds, physical factors and descriptors for those watersheds, and environmental descriptors as well. So we really had a pretty strong database in which to do some exploratory modeling to try and understand what drives flood risk in these watersheds and how we could create a map of likely future flood impacts for these watersheds. So we undertook a variety of modeling approaches because a lot of the data was not distributed normally, and we had all different types of variables to consider in terms of what's the best predictor of flood risk and likely to predict the flood claims in these watersheds. And best model for predicting flooding across the Gulf at the Huck 12 watershed scale included these variables here. So some of them that are pretty obvious, such as precipitation. That's a very likely predictor, and so we weren't surprised to see that in there. Soil conductivity, we had calculated that, an average value for each of the watersheds, and that just has to do with how the soil is able to absorb water. The percent of the watershed in the floodplain also was a strong predictor for the NFIP claims. The slope, the distance to the coastline, the spatial coordinates has a little bit to do about kind of the east versus west portion of the Gulf. It had an influence on the model. And finally, development. So the level of development within each of these watersheds was a strong predictor of the amount of NFIP flood claims within these watersheds as well. So using that model, it had a pretty good level of accuracy. It was about 85%, I believe, in terms of predicting the NFIP claims that we had in our database. So using that model, these are the watersheds that have a 70% probability or higher of having NFIP claims based on the modeling that we did for this analysis. So as I mentioned in the introduction, we really wanted to get towards multi-objective watersheds. So watersheds that not only have a high flood risk and a high likelihood of NFIP claims. That's a really important clarifier there, is that it's more than just flood risk. It's actually where there's a probability of claims. So this does drive the analysis more towards where there are people, where there's residential development. So once we have this map of the high likelihood of future flood claims, the other side of the overlay is the high conservation opportunity, which I'll explain here on the next map. So to develop this Gulf-wide map of the conservation opportunity, we first took the footprint that was developed by the Partnership for Gulf Coast Land Conservation. And that's a group of land trusts across the Gulf of Mexico came together with PGCLC and mapped out their priority areas for land acquisition across the Gulf of Mexico. I'm sure many of you that are on this call are familiar with that product and that data set. So starting with that Gulf-wide footprint and vision map, we said, let's exclude areas from that map that are developed because we're looking for places to acquire and protect open space. And let's calculate the private lands that are available excuse me, within each of these watersheds across the Gulf of Mexico. So taking that kind of approach, GIS approach, this is what we landed on for high conservation opportunity. So these areas that are shown in the maroon here are watersheds that have 20% or more of the area is private. So it's potentially available to purchase, undeveloped, and within the land trust priority areas. And so that's pretty widely distributed across the Gulf of Mexico, as you can see. And I also like to make a point when I show this slide that This is just how we defined high conservation opportunity across the Gulf of Mexico, because we already had the PGCLC map of priorities. If you were to undertake an analysis like this at a state scale or at an estuary scale, there's likely other finer resolution conservation priority data that's available that you could use to do an overlay of high flood risk and conservation opportunity. So the resulting maps shown here shows the overlay between the high likelihood of future flood claims and the high conservation opportunity. So you can see which watersheds really come to light here. The darker the coloring indicates more land within those watersheds is currently undeveloped and available and within the PGCLC footprint. So as a result of this analysis and mapping out these watersheds, it helped us within the Nature Conservancy and working with some of our partners to focus in on some specific areas across the Gulf of Mexico to reach out to folks who work in land conservation and reach out to folks who manage the flood risk in these areas to ask the question, how do you consider purchasing land to reduce flood risk? And if you do that, how do you fund it? Do you have any sort of legislative mandate to be doing that? And if you don't do it, are you interested in learning more? And when we were organizing ourselves to begin to do some outreach in some of these target estuaries across the Gulf of Mexico, it was suggested that we reach out to Mike's crew and partner on the wetland migration outreach that was going on. And it was really a nice fit and worked out really well in that we were reaching out to similar stakeholders in terms of we both wanted to reach a diverse group of folks. We wanted to reach not only people who are working in land trusts and working in environmental management and NGOs, but we also wanted municipal representation, people that handle the FEMA community rating system for their municipality, agency folks, scientists as well. So we both had diverse and similar stakeholder needs. And so by partnering, we were able to kind of have a conversation at each of the workshops about if people are conserving wetlands and conserving wetland migration corridors, and if they are doing that, are they doing it to reduce flood risk in the future or to maintain any sort of flood mitigation benefits that the wetlands are currently providing? As I mentioned, the results from the open space study, so the high flood likelihood watersheds and the high conservation opportunity watersheds, as well as the overlay, is available on coastalresilience.org if you'd like to check that out. One of the interesting findings from this project was that we had access to a database from 2014, and it had all of the different point values for communities enrolled in the FEMA Community Rating System program. And for those of you who are not familiar with it, in a nutshell, the CRS program gives communities credit for different flood mitigation activities that they undertake. And the more credits that they get, the more of a discount they earn for their citizens on their flood insurance. So for example, where I live here in the city of Punta Gorda in Florida, we receive 25% off of our flood insurance for our home each year because of things that the city chooses to do and invest in to reduce our flood risk. And so one of the items within the FEMA community rating system is protection of open space. And so there's already this existing financial incentive for communities to fund land protection, support land protection, because the more land that they protect within the floodplain, the more points they can earn, the more of a discount they can earn for their citizens. And so we took a look across the area of analysis for this project, and there were 343 municipalities, counties, or parishes within or partially within our high priority watersheds that we identified. And as of the 2014 database that we had, only 100 of those communities were enrolled in CRS. And much of the time, communities are not participating in CRS because they don't have the capacity to have someone managing it, or they don't have someone on their staff that can do the GIS work that is necessary to submit some of the paperwork. And so what we're working on now is trying to understand where there is opportunity to help communities either enter the program or move up in the program, if we can help identify these open space opportunities and help them earn more points, or even quantify what they're already protecting. And so we found when we looked into this 2014 database that the average number of points was only 131 out of a possible over 2,000 points. So there was a lot of opportunity dating back to this time, and we think things haven't changed significantly since 2014, but there are some communities that are enrolled in CRS and they have very low level of open space points, and they might be more willing to support land protection within their communities in terms of, you know, proposing restore projects or other types of NIFWIP projects if they know that they can earn these CRS points and increase their rating by doing so. Just a couple of the outcomes from the open space project. This work was, the science portion of the project was funded privately through the Knobloch Family Foundation. And as part of the project, we developed the science and the maps, and then we also had funding within the project to support our state chapters in the 5 Gulf states in terms of due diligence funding for land protection projects that fall within the priority watersheds. And I have a summary slide on that in a minute. And then with the funding that we received from the US Fish and Wildlife Service and the LCCs, we were able to host a series of workshops in partnership with USGS across the Gulf of Mexico, and that's the map that Mike showed earlier. And then finally, as a result of this work, we're bringing a CRS app, which is an app on our decision support tool, to the Gulf of Mexico. It's an app that was developed by the TNC North Carolina chapter, and I'm going to show you a slide about that in a moment here. So as part of the open space project, the original project funded by the Knobloch Foundation, we developed an application process that was internal to TNC where our chapters could apply to the Gulf of Mexico program, and we had an application process that highlighted the flood risk reduction value of each of these projects, where they are located within the priority watersheds, and then we dispersed some of the funding back out to the state chapters to cover staff time and due diligence costs associated with these land acquisitions. And so we were able to support projects in each of the 5 Gulf states. The second outcome from the project is the outreach workshops that we held across the Gulf of Mexico. I think a couple of folks that are even on this call might have been in attendance at some of these, but we were really seeking to have a diverse audience because we feel that the most good can come from the science if the practitioners on the environmental side are working closely with the flood mitigation folks, and also the government agency folks in terms of thinking about these multi-objective projects where we're meeting our conservation objectives, but we're also reducing flood risk across the Gulf of Mexico, which is a real and increasing issue. So you can see the diversity of the types of folks that we had in attendance at these workshops, and we've already made some strong connections at those workshops and been moving forward on projects and project ideas that were developed as part of the discussion at these workshops. So it was really meaningful partnership and collaboration with USGS and also bringing some of these folks together across the Gulf of Mexico. So as I mentioned, TNC North Carolina developed with the TNC Global Marine Team an app on coastal resilience that allows you to explore future protection of open space parcels. And so this was developed in North Carolina and has been used by a handful of communities to earn more CRS points by protecting parts, strategically identifying which parcels to protect, and then it allows them to get a better CRS score and earn their citizens this discount on flood insurance. So as I mentioned, it's an incentive that already exists for land protection. It's just a matter of connecting the land trust community more strongly into this process. So we are currently working with Harrison County, Mississippi to develop the CRS app in the Gulf of Mexico as part of our discussions in the workshop series across the Northern Gulf and in Florida. We presented on the open space project and the wetland migration project, and then had a facilitated discussion in each of the workshops about what future science needs and planning needs folks had, and communities self-identified if they would like to work with us in partnership with us to develop a CRS app in their communities. So we had about 8 communities asked to participate in that, and we selected Harrison County to pilot the CRS app in the Gulf, but we are currently putting together a proposal to fund the other communities that would like to develop the open space app with us. And if there's anyone on the phone that's from a land trust or from a municipality that's interested in partnering on that as well, feel free to shoot me an email. I'd like to finish off sharing a little bit about the Coastal Resilience Tool. As many folks maybe have heard of it and aren't entirely familiar, but the Coastal Resilience Tool is a free online web mapping tool that's useful for resilience and restoration planning. You can overlay your own local data with our data layers and our apps and tools. So if you have a planning process or a decision or a science project going on in which you could use the viewer for meeting facilitation or just to explore a variety of options, you can request that we add your local data to the decision support tool, and we can do that so you can overlay your own local data with the science and tools that we've developed and also the science that partners have developed. So for example, we have the outputs from Mike's Wetland Migration Project on the decision support tool as well. And so as I mentioned, the FEMA Community Rating System app is being developed right now for Mississippi, for Harrison County, Mississippi, but we'd like to expand that out to multiple municipalities across the Gulf. And there's even potentially an opportunity that we can turn some of the science that's in Sinead's pending publication potentially into an app or something that can make it usable and accessible to more municipal planners and staff within cities and counties. So with that, I'd like to thank Greg for putting on this presentation today, and I'd be happy to answer any questions about the open space study or the outreach workshops that we had, and I know Mike is available to take questions now as well.
Thanks, Chris and Mike. I don't have any questions yet in the question box, but you guys could submit questions via the question box, or you could use the little raise your hand function in the attendee box, and we will unmute you so that you can ask your question. But in the meantime, I'm going to launch one last little poll here. I'm just curious how people think how much they think they might be able to apply this in their work in the future. And feel free to go ahead and enter questions in the question box or raise your hand as you're working. That's good. We got one question came in from Sinead. So in just a second, I'm going to close this poll. We got about 77% of people have voted. I'm getting ready to close it. So let me see. Oops, let me share the results. Pretty positive response. Nice audience, friendly audience. So we have a question from Sinead, and I'm going to unmute you so you can go ahead and ask your question if you'd like. Hold on. You there, Sinead? Sinead? Well, I'll read her question. She says, Chris, how did you settle on Harrison County and what factors made it more appealing? And Sinead's apologizing that she's got very poor service. She's in her car.
Yep, so that's a good question. So we settled on Harrison County #1 because they expressed interest, and their GIS manager, who was familiar with the CRS project, said that they had their next review was within 18 months from now, and he felt that they had an opportunity to improve their open space points. Also, we had some conversations with some of the folks who work in land trusts in that area who wanted to learn more about CRS as well, who are going to be functioning as kind of beta testers in the steering committee for the development of that app. And there were several other qualified communities as well. Some of them have their update a little further out. Some of them are kind of mostly getting to the point where they're going to max out on open space points, but they like the idea of an app in terms of just helping streamline their process for paperwork and helping the community understand that protecting open space saves them money. But yeah, that's how we landed on Harrison County, and we should be completed with that and launch that in March. And every time we do this, the process becomes more streamlined and cheaper. So we're hoping that if we can bundle several communities together, we can provide that app to several communities at once. And you know, we're always looking for ideas and opportunities to incorporate more science. So as I mentioned, it might be worthwhile to have a conversation about what we can do to make the wetland migration data and some of those key areas that Sinead highlighted in our workshops kind of really highlight that message and show those visually to communities that we work with and other people work with across the Gulf.
Great. We have a question from Greg Wathen, and let's see. You're unmuted now, Greg. You want to ask your question?
Yeah, can you hear me okay?
Yeah.
Yeah, I just had a question for either Mike or Chris regarding the hurricanes that we had this past fall, especially Harvey and Irma, whether those events caused any surprises in terms of where we saw flooding as opposed to where you guys were, where you all estimated the flooding would occur. And then secondly, are there any communities that were affected by those events that are expressing an interest in developing resilience strategies?
Well, I can speak to we weren't really surprised at the impacts in terms of where they are. And in fact, a lot of the Harvey area shows up on the open space maps as an area where it's not too late to make investments in land protection to help with flood risk. And indeed, it sounds like the process there post Harvey will be seriously considering buyouts, and we're actually going to be starting a project that takes the open space project that we did Gulf-wide and zooms it in more to the Harvey region to understand what role future buyouts and open space protection can play. We hope to be able to evaluate the impacts more quantitatively for Harvey and Irma, but it will take some time to be able to do that, to be able to get access to the NFIP claims that actually are derived from the storms. So, there have been some anecdotal stories about the role that mangroves may have played in certain areas in Florida, but it is hard to say without really quantifying that and having real science behind it.
Great, thanks.
I don't have any more questions coming in, but I have a question. I wondered, Chris, if how many of the local government or community planners that you guys had at these workshops, if there were any that were completely unaware of the open space bonus that they would get through CRS, if that was news to them.
Well, the folks in these communities that work with CRS already are familiar with it. But what I've been told is that sometimes the process is too daunting, so they'll just kind of skim through it and do the minimum amount of effort to arrive at some sort of a documentation. And so a few folks said, you know, we could really benefit from a more systematic process and an app that can do this for us. NOAA also recently put out some guidance on how to calculate CRS open space points with some a GIS workflow, because really the guidance from FEMA is not that specific, and so NOAA put out a workflow for them to do it. But it was more the folks that work in land conservation that I was surprised some of them had not known the specifics or really heard or known that open space was worth points in CRS. And so we've had some conversations about hosting some workshops, or at least maybe a half-day meeting where we bring together in specific communities the CRS folks and the floodplain managers with the people that are active in land conservation in that area, and having a half-day meeting where we go over the basics, we talk about what folks have planned, and if there's any prioritizing that could go on based on CRS or collaboration, to start to bridge that connection. But in terms of the reaction to the wetland migration data, that was much more varied in terms of some folks said, yes, we could definitely use this, we'll figure out a way to use it, or we're already doing something like this. In Florida, there were quite a few examples where people were already starting to think about wetland migration, whereas in some of the other communities, the response was more, okay, I personally care about this, but I have no mandate to be working on this within my job. And so in those places, they want it is taking place, so they could use that as examples of how the information could be used, because in their current body of work, they were not tasked with considering it. So they had a harder time seeing how to fit it in to their scope of work. That was more the municipal folks.
Thank you. Thank you for two really excellent presentations and a really great outreach component on this project. So I don't see any more questions right now, so that's going to be the end of our webinar. Thank you everybody for attending, and we do have another webinar scheduled for December 13th that's all about modeling flow in rivers and streams throughout the whole Gulf Coastal Plains and Ozarks region. Thanks very much.
Thank you, Greg.